everyone, welcome back to another episode of Once Upon a Lecture. Today, in the Enchanted Forest, I would love to teach you about the measures of central tendency. Measures of central tendency include three main measurements: mode, median, and the mean. You may be familiar with these terms from your previous statistics classes. For example, the mode is the score that occurs most often. The median is the score in the center of the distribution, and the mean we all know is the average. But we're going to go into a little more detail to talk about each of these measurements, and more importantly, we'll understand when we should use which measure to describe a particular set of data. Let's get started. So if we think about the term central tendency, the word central causes us to think about the word center or the word middle. The word tendency causes us to think of synonyms like likelihood, chances, etc. So ultimately, when we talk about measures of central tendency, we're talking about the likelihood that scores will be concentrated near the middle of a distribution. Now, there are three main measures of central tendency: the mode, the median, and the mean. Let's start by talking about the mode. The mode is the easiest measure of central tendency to identify. It is unfortunately also the least useful in the sense that the mode cannot be used for any sort of inferential statistics. If you remember back in lecture 1 by Princess Jasmine, she taught us about the two different types of statistics: descriptive and inferential. For inferential statistics, we often use the measurements and values of given samples to infer or generalize to larger populations from which they came. With descriptive statistics, we are not able to do that, and so a mode is another example of a descriptive statistic. It cannot be used to make any sort of inferences about a larger population. And the way that we identify the mode is basically by looking at which score occurred most often. In other words, the mode is the most frequently occurring score in a distribution. And it can be identified by looking at the score that has the highest frequency value. So if you remember in our previous two lectures, we talked a lot about frequency distributions and frequency. So basically, whichever number has the highest value in that F frequency column will be your mode. Modes are typically used for nominal or categorical data. If you remember, we talked about different types of scales, and we talked about how sometimes data can be nominal or categorical, meaning it's represented by a word instead of a number. And what we often have to do is assign a number to a word when we calculate any sort of statistical analysis. So the mode is often used for nominal or categorical data. Additionally, distributions can have more than one mode. If a distribution has two modes, we call that bimodal, and anything beyond two modes can be called multimodal. The median is the second measure of central tendency that we're going to discuss. The median is defined as the score in a distribution that separates the top 50% from the bottom 50%. It is also known as the score at the 50th percentile, and the word percentile means everything at a given score or below. So for example, if you were talking about something at the 65th percentile, it means everything at 65%, but also 64, 63, 62, etc. So everything that leads up to 65%. In order to calculate the median, our data has to be in order or in an ordinal scale in order for us to be able to calculate which score is exactly in the middle. Sometimes the median can be the best descriptive measure of central tendency. Why? Because the median is not influenced by deviant scores or outliers. For example, the mean or the average, because it takes into consideration all of the data points in a particular distribution. Any sort of outlier, which is an extremely high or an extremely low score, can skew our average. But with the median, if you have outliers or skewed data, it is often the best measurement to use to describe a particular data set. And additionally, the median is dependent upon the number of scores up to that midpoint. It does not depend on the value of the scores. So whether you have high scores or low scores, in the instance of our outliers, it doesn't really matter because the median tells us the position instead of the value of the number that is at that midpoint. Don't worry, it'll make much more sense once we start calculating. For example, let's imagine that you have the following scores in a set of data. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. To calculate the median, we need to find the score that is exactly in the middle of the distribution. In order to find the score that's in the middle of the distribution, we will count how many total data points we have and divide by 2. So because we have an even number of data points, the median will have to be between the 5th score and the 6th score. In other words, we have to take the average of the two numbers in the middle. So you could add 5 plus 6, which is 11, and divide by 2, and that will give you 5.5. We also know that the midpoint between 5 and 6 will also be 5.5. So in this case, our median, our middle value, is going to be 5.5. So that means 1, 2, 3, 4, and 5 are 50% of the distribution, and 6, 7, 8, 9, and 10 are the other 50% of the distribution. Therefore, 5.5 is the midpoint of our set of data. We have two different formulas to use when we calculate median. If the distribution has an even number, in other words, if there is an even n, an even number of data points in your data set, the formula looks like this. So the formula says that the median is equal to the nth over 2 score, which is 10 over 2, gives us 5. So the 5th score plus n over 2 plus 1, which is going to be the 6th score. So we have to take the average of the 5th score and the 6th score, take the average of that, and that will give us our median. So the median is equal to the 5th score plus the 6th score over 2. If the distribution has an odd number, meaning an odd number of data points, that formula is fairly simpler. All you have to do is n plus 1 over 2. If the distribution has an odd number of data points, if you have an odd n, all you have to do is place n in the numerator, add 1, and divide by 2. So for example, if I have 9 data points, 9 plus 1 is 10, divided by 2 will give me a 5. So it's fairly easier to calculate the median when you have an odd number of data points than it is for an even number of data points. Let's try one together. Here are the data for the correctly solved number of riddles solved by a group of 20 dwarfs. 2, 0, 6, 5, 5, 2, 1, 7, etc. I don't need to read it for you. You can see it for yourself. So the first question we need to answer, is n even or is n odd? If you count the data points or simply read the data in the first bullet point, it says that these are data for 20 different dwarves who have been solving riddles. 20 is clearly an even number. So to answer the question, is n even or odd? We know that n is even because 20 is an even number. Unfortunately, that means that we need to use the more complicated formula, but as you'll notice and practice, you'll eventually get the hang of it. So here's the formula that we need for the even number n. We can see that the nth over the second score plus the nth over the second score plus 1 will give us the formula we need. So if 20 is our n, 20 divided by 2 will give us 10. So we're going to look at the position in the 10th score, and 20 over 2 plus 1 is going to give us the 11th score. So what we need to do is we need to find the 10th score and the 11th score. And remember, the median gives us the 50% marker. So what is 50% of 20? 10. But because we have an even number of n, an even number of data points, we need to split the average of the 10th score and the 11th score. So the first thing we want to do is take this set of data and organize it. And we know that the best way to organize data is in a frequency distribution. So let's go ahead and set up a frequency distribution. Once we put the scores into a frequency distribution, you're going to have the x value, which is the score, the f value, which is the frequency, how many times each score occurred. When we look at the data set that is separated by commas there, we can see that several of those data points have occurred more than once. Immediately, if you can see that certain data points are occurring more than once, you know that you're going to have an F column and you're going to have frequency. So after you have your X column for the scores and you have the frequency column to label how many times each score occurred, you're also going to need to have the cumulative frequency column, which is labeled cum-F. If you remember in our discussion on frequency distribution that Princess Ariel taught us, she explains in detail how to calculate frequency and cumulative frequency. So when we talk about finding the position of the 10th score or the 11th score or any score, what we're going to be doing is we're going to be looking for this position in the cumulative frequency column, which is this last one right here. So once you calculate cumulative frequency, remember that the top line is going to be the total number of data points you have. We had 20 data points for 20 dwarfs, so 20 is going to go in that top column. 20 minus 1 gives us 19. 19 minus 3 gives us 16. 16 minus 2 gives us 14. 14 minus 4 gives us 10. 10 minus 3 gives us 7. 7 minus 3 gives us 4. 4 minus 2 gives us 2. And 2 minus 2 gives us 0. So that is how you calculate the cumulative frequency. So now that we have the cumulative frequency column, what we need to do is find the value in the 10th position. In other words, we have to look in the cumulative frequency column and find the number 10. Once you've found the number 10 in the cumulative frequency column, look at what score, what value corresponds to that cumulative frequency. Then we need to do the same thing for the 11th score. Now, if you look at the cumulative frequency column, you may notice that there is no number 11 in its own box. However, we see that there is 10, and then the next number above that is going to be 14. That means that between 10 and 14 lie the numbers 11, 12, 13, and 14. So once again, if we look at the cumulative frequency column in the 10th position, we slide our finger across to this score that corresponds to the 10th position, and we see that that value is 3. If we are trying to find the score relative to the 11th position, we're going to have to look up above one box, and we will see that the score of 4 corresponds to everything in the 11th, 12th, 13th, and 14th position. So once again, we can see that the score corresponding to the 10th position is 3, and the score corresponding to the 11th, 12th, 13th, and 14th position is 4. And our formula says that we need to take the average of those two values. Remember, you're taking the average of the score, you are not taking the average of the cumulative frequency. So the score at the 10th position is 3. And the score at the 11th position is 4. Remember, the cumulative frequency number, the number that appears in the cumulative frequency column, tells you the position, not the value. In order to find the value, you need to see which score corresponds with that cumulative frequency value. So now that we know 3 corresponds with the 10th position and 4 corresponds with the 11th, we know that we need to take the average of the two. So 3 plus 4 is 7, and if we divide 7 by 2, we get 3.5. Therefore, the median of this data set is 3.5. Now let's imagine that we had 25 dwarves who decided to solve riddles as opposed to the 20 in our previous example. Looking at this data set, we can see that the number 25 represents the total number of data points we have. By the way, a great way to calculate the total number of data points you have if it's not given to you is simply by adding up the numbers in the frequency column. 3 plus 4 plus 6 plus 2 plus 5 plus 3 plus 2 plus 1 will give you a total of 25. So by adding up the frequency column, you are able to calculate the total number n. So let's get back to the median. If we know that n is 25, we can also agree that 25 is an odd number. We know that the formula for finding the median in an odd set of data points is going to be n plus 1 over 2. In this case, our n is 25. If we add 1 to 25, we're going to get 26, and 26 divided by 2 gives us 13. In other words, our median score, our middle score, is going to lie in the 13th position of our cumulative frequency. So if we look at cumulative frequency and we try to find the 13th score, we notice that we have 12 and we also have 18. So what that means is everything above 12, meaning 13, 14, 15, 16, 17, and 18 are going to correspond to the score of 8. 13 tells us the position of the 13th score in the distribution. Once we identify the 13th score, then we have identified the score that is the median, the middle of our distribution. So we need to find 13 in the cumulative frequency column. By looking at this column, we see that the closest thing we have to 13 is the number 12. Above 12, we have everything from 13 to 18. That means that the score of 8 is going to correspond to numbers in the 13th, 14th, 15th, 16th, 17th, and 18th positions. So the score that is the median is going to be 8. The median that we calculated was in the 13th position. Once you find the position for the score, you need to identify the score that corresponds to that particular position. In this case, that score is 8. That means that 8 is the median of our distribution, which occurs at the 13th position of the entire data set. So now that we've learned how to calculate the mode and the median, let's talk about calculating the mean or the average. The most common measure of central tendency that we use for both descriptive and inferential statistics is the average or the mean. The mean is basically the sum of the scores of all of the data points in our distribution divided by the total number of scores we have, in other words, n. So the symbol for the sample mean is x with a bar over it, and the symbol for population mean is mu. Given the fact that most of our discussion will revolve around samples, we're going to illustrate it with x bar. The mean is considered to be the most useful of all three measures of central tendency. Why? Because it is based on all of the data. It encompasses every single data point in the distribution. It is also considered to be the most unbiased measure of central tendency for that same reason. No matter how low or how high the scores are, they go into calculating the mean. And therefore, it is considered to be the most reliable of all the measures of central tendency, and it is least likely to change if you were to resample. So going back to our concept of why we use samples, it's often impossible for us to test entire large populations, given that would take so many resources and so much time. So what we often do is we take samples from populations. The idea is the more samples we take, the closer we are to identifying the population mean. So the mean, the average of a sample, is least likely to change if you were to continue sampling sample after sample after sample. If we kept taking successive samples over and over from a population, eventually, hopefully, our sample mean would be the same as the population mean. But what are some disadvantages of using the mean? Well, we do know that because the mean takes into consideration all of the scores in a distribution, no matter how low or how high they are, that means that it's possible that we will have some skewed numbers, some skewed data in our data set because we will be considering extreme scores or outliers. This will further lead to skewness in our distribution, which is something that you typically don't want to have. You don't want to have outliers in your data set. Additionally, if you do have these outliers, or if you do have extreme scores that tend to pull your mean down or hike it up a lot, that's going to cause misrepresentation in your data. It would also cause misrepresentation in your graphs. So let's take a look at the formula for calculating the mean. We have two different formulas here. One formula is for calculating the sample mean and the other formula is for calculating the population mean. Technically, the calculations you are performing are going to be identical for both a sample mean and a population mean. However, I think it's helpful to familiarize yourself with the different symbols used for a sample mean versus a population mean. So once again, X bar represents the sample mean and it is equal to the sum, which is what we see here, the sigma, the sum of X, meaning the sum of all of the scores, divided by lowercase n, where n represents the number of data points you have. Similarly, for a population mean, instead of X bar, you have mu, and mu is equal to the sum of X, the sum of all your scores, divided by capital N, the number of data points in your population. So I know what you're thinking. What happens if I have a frequency distribution? What happens if I have scores that occurred more than once? Well, then that formula slightly changes and it looks like this. The sum of the frequency multiplied by the score divided by n. So in other words, to calculate the average for a frequency distribution, we're going to need to add one more column called f of x. When you see two symbols placed side by side each other in mathematics, that means that those numbers will be multiplied. So all this means is that you're going to take each score and multiply it by the number of times it occurred in the data set. By looking at this list of correctly solved riddles, we can see that some scores occurred more than once. So we need to create this additional column called f of x. What we need to do is multiply each score by its frequency and put those numbers in the f of x column. So x is 10 and f is 1. If you do 10 times 1, you're going to get 10. If you multiply 9, which is the score, by the number of times it occurred in the data set, which is 3, 9 times 3 will give us 27. If you multiply 8, the score, by the number of times it occurred, which is 2, you're going to get 16. So once you complete the entire column of f of x, this is what you should get. Everything in the f of x column represents the score multiplied by the frequency, the score multiplied by the number of times it occurred. So now let's try to calculate this mean together. Once the f of x column is complete, we need to add up the total of all of the f of x scores. So ultimately what you're doing is finding the sum of the f of x column, which is symbolized by the numerator of our formula, the sum of f of x. In other words, what you're doing is adding 10 plus 27 plus 16, everything that is highlighted by the pink bracket. Once you add all of those values together, you should get a total of 150. 150 is now going to be the numerator that we plug into our formula. Let me just remind you that the formula for the sample mean when you have frequency is the sum of f of x divided by n. N is equal to the number of data points that we have. So if we want to calculate how many data points we have, we cannot count how many x scores we have because some of those scores occurred more than once. So the way that you would calculate n is by adding up all of the numbers in the f frequency column. So once we calculate that, we see that n is equal to 25. So to complete the formula, the numerator is 150, the denominator is 25. The sum of f of x is 150. The total number of data points we have is 25. If we divide those, we get the quotient of 6. Therefore, that means that the average of our distribution is 6. So now that we've talked about calculating mean, median, and mode, there's one last concept that I wanted to show you, and that is called the mean as the balancing point. So what does this mean? Well, the mean is often considered to be the center of the distribution. So if you remember back to the title of this lecture, Measures of Central Tendency, the mean tends to be at the center. And it is often considered to be a balancing point between what is above the mean and what is below the mean. So this is a concept that illustrates just that. In a distribution, some values are greater than the mean and some are smaller. The sum of all of the deviations from the mean will be 0. So in other words, that means if we add up all of the positive and negative differences from the mean, the result of that will be 0. And if you're thinking to yourself, what is a deviation? A deviation basically means something that is different, right? Something that deviates from the norm, or in this case, deviates from the mean. So anything that is not the mean itself, anything that is not the average, is considered a deviant from the mean. Well, in our previous example, the mean was 6. If you have a data point of 8, that means that the score of 8 deviates from the mean by 2 points, by positive 2 points. If you have a score of 4 and you know that the mean is 6, that means that our score of 4 deviates from the mean by negative 2 points. So in other words, if you add negative 2 and positive 2, it's going to give you 0. So let's talk about this in a little bit more detail with an example. So 9 of my dwarf friends were given 20 minutes to find diamonds in their mine. The number of diamonds each one found was recorded. So here are the data that we collected. One dwarf found 10 diamonds, 2 dwarfs found 8 diamonds, 1 dwarf found 7 diamonds, 6 diamonds were found by 1 dwarf, etc., etc. So X represents the number of diamonds that were found, and F represents the number of dwarves that found that many diamonds. So we need to add one more column, the f of x column, since we have some scores that occurred more than once. So if you remember, we previously just discussed that in order to calculate the f of x column, all we need to do is multiply x by f. However, we also need to add a new column in which we will be subtracting each score from the mean. So once you have your f of x column, what we're going to have to do is calculate the mean. Once we've got the mean calculated, we are then going to see how much each score differs from the mean. And again, the score is represented here by the number in the x column. So we're going to subtract the number in the x column from the mean for every score down the line. And the last thing we need to do is add the f multiplied by the mean minus the score column. So that's this last column right here. Because there are certain scores that occurred more than once, because we have frequency, after we find the deviation of each score from the mean, we also need to multiply that by its frequency. So let's start filling in the columns, and I promise this is much less overwhelming than it sounds. Let's start with the f of x column. We know that to calculate the f of x column, we need to multiply x by f. So 10 times 1 is 10, 8 times 2 is 16, 7 times 1 is 7, 6 times 1 is 6, 5 times 1 is 5, 4 times 1 is 4, and 3 times 2 is 6. So that column should be fairly easy to calculate. Now remember, in order to calculate the mean, our formula says that in the numerator we need to know the sum of the f of x column and divide it by n. If we add up the total of the f of x column, we get a sum of 54. 54 is going to go into our numerator for our mean formula. Now we also need to calculate n. If you remember, n is calculated by adding up the frequency column. So if we add 1 plus 2 plus 1 plus 1 plus 1 plus 1 plus 2, we get a total of 9. And if you remember, in the original example, I told you that 9 of my dwarf friends were participating in this diamond finding competition. So we're going to take 54 in the numerator, the sum of f of x, and divide it by 9, the n, the total number of data points we have, and we get an average of 6. Therefore, we know that the mean is 6. Now, keeping that average in mind, we are going to now fill in the next column. If you look at that next column, it says x minus x bar. In other words, the score minus the mean. So we're going to look in the x column. The first number we see in the x column is 10. And we know that our mean is 6. So what we need to do is subtract 10 minus 6, and we get 4. Then we do the same thing with the number 8. 8 is the score minus the mean, which is 6. We get a total of 2. If we look at the score of 7 and we subtract the mean, we get 1. Then we see a score of 6. 6, in fact, is our mean, and 6 minus 6 will give us a value of 0. Now we start to notice that we have numbers in our distribution that are below the mean, that are below 6. So you can imagine that if you're going to subtract a smaller number from 6, you're going to end up with a negative number. So if we subtract 5 minus 6, we're left with negative 1. 4 minus 6, we are left with negative 2. And 3 minus 6, we are left with negative 3. So the last step is to multiply each deviation by the frequency, or the number of times that score occurred. So now we're going to be focusing on the F column and the X minus X bar column. If we look at the first line, the score of 10 occurred once. After we subtracted the score from the mean, we were left with the difference of 4. If we do 1 times 4, we are left with 4, and that is the number that goes into the very last column, the first line of the very last column. Let's move down to the next score we have, which is 8. We can see that the score of 8 occurred 2 times. When we subtracted 8 from the mean, we were left with 2. So now we take the frequency of 2 and we multiply it by the difference of 2, and we get 4. Moving down the line, the score of 7 occurred once. We're going to take that frequency of 1 and multiply it by the difference of the score from the mean, which is also 1 in this case. So 1 times 1 is 1. We do the same thing for the scores of 6, 5, and 4, because those all occurred one time. And ultimately, you're multiplying the frequency by the difference in the X minus X bar column. The very last score we have was 3, and 3 occurred a total of 2 times. If we multiply 2 by the difference of 3 minus 6, we get 2 times negative 3, which gives us negative 6. Now let's take a look at that last column, where we've multiplied frequency by the difference of each score minus the mean. We have 4 plus 4 plus 1, minus 1 minus 2 minus 6. So if you take the sum of this column, you will notice that the total adds up to 0. And that is exactly why we say that the mean is the balancing point. So in this lecture, we've learned about the 3 main measures of central tendency: the mode, the most frequently occurring score, the median, which is the center of our distribution, and the mean, which is the average of all of the data points in our distribution. Hopefully this was helpful for you to understand measures of central tendency. Feel free to drop some questions in the comments below if you have any, and I'll be happy to answer them as soon as I can. Thank you so much for watching, and I hope to see you next time on Once Upon a Lecture.